So yesterday we were talking about solving exponential equations, and in those exponential equations we had some base raised to a power equals another base. Now in every one of those problems we could write both bases as the same. So in this case I would be able to write this as 6 raised to some power, and then this over here would also be 6 to some power. But as I'm looking at this problem, I don't see that's the case here. I don't see that I can't rewrite 15 as 6 raised to some power. So the way that we solve these exponential equations is by using logarithms. The first thing we're going to do is we're going to take the log of both sides. Okay? So the first thing we're going to do is we're going to take the natural log of both sides. Because remember, the opposite of raising something to power is logarithms. So what I'm going to do is I'm going to take the natural log of 6 to the 5x equals the natural log of 15. So I took the natural log of both sides, and the reason I did that is because remember with the laws of logarithms, we can take this 5x and we can actually bring it to the front of our natural log of 6. So I can actually rewrite that natural log of 6 to the 5x. I could take that 5x and bring it to the front by the laws of logarithms, and I'll get that 5x times the natural log of 6 equals the natural log of 15. So now, if I want to just finish solving this equation, I could divide both sides, because remember I'm trying to solve for this x right here. So what I can do is I can divide both sides by 5, natural log of 6, 5, natural log of 6, and when I do that over here, what we see is we see that that 5 cancels with that 5, natural log of 6 cancels with that natural log of 6, and what I'm left with is just that x. So what I'll have left, I'll have that x equals the natural log of 15 divided by 5, natural log of 16. Now we can enter that into our calculator, and when we enter that into our calculator, we're able to see that we get 0.3022. Okay, so there is our answer right there. So let's look at another example. Remember, the first thing we're going to do is we're going to take the natural log of both sides. So what I'm going to do is I'm going to take the natural log of 2 raised to the x equals the natural log of 10. Now I'm going to bring my exponent here to the front, and I'll get x times the natural log of 2 equals the natural log of 10. And lastly, what I can do is I can divide both sides by the natural log of 2. My natural log of 2's cancel each other out, and I get that x equals my natural log of 10 divided by my natural log of 2. And when I enter that into the calculator, I get 3.322. And there's my answer there. Now our final example is a little bit more complicated, because when we look at our exponent, we have a binomial up there. We have 2x plus 3 instead of just something to the x. So remember, first step is to take the natural log of both sides. So I'm going to take the natural log of both sides. So get natural log of 21 raised to the 2x plus 3 power equals the natural log of 100. Now I'm going to take my entire exponent, so I'm going to take the entire 2x plus 3 and bring it to the front. So I have 2x plus 3 times the natural log of 21 equals the natural log of 100. So now here's a trick when I'm doing this one. I could distribute that natural log of 21, but before I do that, I'm actually going to divide both sides by the natural log of 21, because I think that's going to make our lives a little bit easier. Because if I look here, that natural log of 21 will cancel each other out, and then I'll be left with just 2x plus 3 equals whatever the natural log of 100 divided by the natural log of 21 is. And when we answer that into our calculator, we get that that's 1.513. So now I can just solve this equation just like I normally do. I'm going to subtract 3 from both sides. I'll get that 2x equals negative 1.48. And then I can divide both sides by 2. And when I divide that by 2, I get that x equals negative 0.743. And there's my answer for x. So, just in review, our steps are, the first thing we're going to do is we're going to take the natural log of both sides. Then we're going to bring our exponent down, or bring the exponent to the front. by the laws of logarithms. And then the third thing we're going to do is just solve the equation. Okay? And that's solving exponential equations. Okay, one quick thing I want to say before I go is I want to talk about entering into the calculator. So let's say we have the natural log of 100 divided by the natural log of 2. So I could enter this in the calculator, right? I would enter in the natural log, and then it gives me this open parenthesis of 100. Now what I need to make sure I do is I need to make sure I close that parenthesis, and then I'm going to divide that by the natural log of 2. So this right here is what your equation needs to look like when you enter in the calculator. Say you didn't close the parenthesis. What this would look like, this would look like the natural log of 100 divided by the natural log of 2. So you see how this right here is different because you're missing this parenthesis right there? So let's look at what the two different results that I get. So if I do the natural log of 100 divided by the natural log of 2, with the closed parentheses, I get 6.64. When I do it without the parentheses, the natural log of 100 divided by the natural log of 2, what I get is 4.97. So you see how this gives me two very different answers? So you need to make sure that you are putting that parenthesis to tell the calculator that you want to do the natural log of 100. Down here, you're telling the calculator to do the natural log of 100 divided by the natural log of 2. So you're telling it to do this entire thing first as 100 divided by natural log of 2, and then take the natural log of it. Here, you're doing this natural log of 100, you're doing this natural log of 2, and you're dividing the 2. Okay? So this is a very important thing. Very important that you remember that you need to put your parentheses around your numbers.